A very good morning, all of you. Today's session, I will start the most important technique in metal forming, that is forging process. So far, we discussed about the uh, what is meant by a metal forming process. Okay, in detail, classification of metal forming process. Also, we studied the hot working and cold working process. So, if you see the classification of metal forming process, so basically we have the two types. And that is the first one based on the nature of forces acting. Okay, the based on the nature of forces applied on the workpiece. In that we have the again five types. That is direct compression type applied to the workpiece. Okay, the force type is compression. The compression force is applied on the workpiece, the surface of the workpiece. Example is forging and rolling. Okay, also we have the indirect compression type process, wire drawing, okay, or extrusion process. Here combination of all the forces. The tensile force is required to extract the product from the billet. Also we have the tension type process, bending type process, and shearing type process. Also we seen based on working temperature of the material, we have the two types, that is hot working condition and cold working conditions. Say there will be increase or decrease in the temperature if you heat the that metal during operation. There will be vary in the temperature, that will be changes the crystal structure of the material. Once it starts the recrystallization, means there will be changes in the that structure of the material. That means deformation of grains, new grains starts, new set of undeformed grains are starts to create there, that we call as the recrystallization temperature. If you working above recrystallization temperature, the working temperature of the metal is above recrystallization temperature, that we call as the hot working condition. If you work below recrystallization temperature, that we call as the cold working condition. Okay, so recrystallization means there will be changes in the crystal structure. What is my crystal structure? That all we studied in the material science subject. Okay, we have the different atoms bonded to each other. It may be in BCC, FCC, okay, or simple cubic. If you see the simple cubic structure, a total corner of the in simple cubic is total 8. In that have the different atoms arrangement. Okay, if we heat that material, there will be changes of the that crystal structures, that we call as the recrystallization, the formation of new grains after heating. Okay, now today we say the first type of the forging, that is metal forming, that is forging. So also we studied a differentiate between hot working condition and cold working condition. If we see the first one, depending on the working temperature of the metal is above its recrystallization temperature, that we call as the hot working condition. If we see the cold working temperature is below recrystallization temperature. Okay, so above recrystallization temperature means you have to needs to add some heating here, needs to additional equipments for heating the workpiece. But here cold working condition, workpiece is not heated. Okay, if you see the third one, stress required for deforming the metal is low, because the heat is added. Due to heat there will be crystalline structure changes. Due to that, the stress required is minimum to operate is carried out at high temperatures. But in cold working, the greater stress is required to deform the metal in its cold state. Okay. If we say a fourth one, no strain hardening effects. Hence, components do not require stress relieving treatments here because of workplace's heating condition. No strain hardening effects are required here. But here, some several residual stresses are induced in the metal due to strain hardening effect requires the stress relieving treatments here. If we see the fifth one, at higher temperature, grain properties of the metal are refined and physical properties are improved because of that heating the workpiece. Here, no grain refinement, however, strain hardening increases strength and hardness of the metal. With the extra effect required to increase the strength and hardness that we call as the strain hardening effect. Large size components cannot be hot worked here. Okay, but with the help of cold working, it is not suitable for large components. You see the accuracy and dimensional controls of the parts. Here we have the poor accuracy and dimension that we call as the tolerance. We get the less tolerance parts with the help of hot working condition. But by using cold, we will get the relatively compatible in accuracy and with cold closed tolerance. If you see the eighth one, hot working leads to poor surface finish on the part. This is most important. But with the help of cold working condition, the result in the better surface finish. Okay, these are the some differences in between hot working condition and cold working condition. So many times in exam, this question comes differentiate between hot working process and cold working process. Now we'll go to the first technique in the metal forming, that is forging. Okay, forging is a type of manufacturing process. Okay, but wherein metal is heated to its plastic state. That means above recrystallization temperature, and then deformed to the desired shape and size by the application of compressive forces. The compressive forces application means, for example, with the help of hammer. Okay, with the help of hammer, the force is applied to the surface of the workpiece. Also, with the help of press, some automatic press machines are available to form the objects. Also, with the help of rollers. Okay, if the compressive force is applied manually by using some specific tools that we call as the hand forging. Okay, and if the compressive force is applied using machines, then it is called as the power forging. Understood? See, the forging, the workpiece is compressed between two opposing dies so that the die shape are imparted to the workpiece. Forging the type of manufacturing process where in a metal is heated to its plastic state, that means above recrystallization temperature, and then deformed to the desired shape and size by the application of compressive forces. Okay, the forging is nothing but it is one type of the manufacturing process, comes under in the metal forming without removing the material from the object. That metal should be formed with the required size and shape. Now the compressive force application is done with the help of hammer, press and rolls. Okay, as a direct compressive force is acting on the surface of the workpiece for the formation of the object. If the compression force is applied manually, okay, with the help of some tools, hand tools or hammer, that we call as the hand forging. And if the compression force is applied using machines, that we call as the power forging. Okay, if we say today we have various machines and equipments are used for producing quality forged components. Okay, uh, forging can performed with the help of the blacksmith with hand tools such as hammer, anvil, and tongs. Okay, what is my blacksmith? Yes, the blacksmith is a person who creates objects by forging the metal. Usually they use iron or steel using hand tools like hammer, anvil, chisel. Okay. Now next we say a classification of forging process. Okay, the forging process can be classified by the degree to which the flow of the work material is constrained during the process. Okay, mainly we have the two types: open die forging and closed die forging. Also one more we have, that is third one, that is impression die forging, that also we see. Okay, just write down the classification of forging process. All of understood the meaning of forging? It is one type of the manufacturing process where metal is heated to its plastic state, means above recrystallization temperature, and then deformation to its desired shape and size of the object with the help of compressive forces. This is nothing but forging. Now next write down the main types of the forging process. The first one is open die forging, second one is the closed die forging. One other we have, that is impression die forging. In the next, the first one you have the open die forging, or it is also called as the Smith forging. Okay, open die forging is also called as the Smith forging. For flat die forging, that is carried between flat dies that do not enclose the workpiece. If you see, the open dies are there here, two dies, one is upper die, a lower one is the lower die. This is fixed one. In between upper die and lower die, have to place the metal. So this billet, this word is nothing but hot metal is placed in between the two dies. Okay. Now the compressive force is applied on externally to the surface of the upper die. So once you apply the force on the upper die, what happens? The metal flow perpendicular to the applied force. If you see the shape of the object, initially it is have square. Okay, after applying the force, we get the ellipse. Means the metal is flowing outside from the die because of the application of the compression force. So the dies are usually flat in shape, but some have simple, some different shapes, that may be round, concave, or convex surface for specialized operations. So the heated workpiece metal is placed on the bottom die, which may be, can say, anvil or press bed, while the top die attached to the some machines here. It may be reciprocating a ram that strikes repeatedly to the deform the workpiece. The operator needs to orient the position of the workpiece before each stroke of the ram in order to get the desired shape and size. So for this, different machines are available for operating the this forging technique. If you say some advantages of open die forging, see, this process is relatively simple. There is not a skilled person is required to operate this process. Okay, make use of simple and inexpensive dies here. Just have to use the dies and some required equipments to operate the this operation. If you see the some disadvantages of open die forging process, see, this process is only limited to simple shapes. To make square into circle or ellipse, it is not useful for the big products. Okay, and also very difficult to maintain the close tolerances. There may be close tolerance means there may vary in the dimension. It's most important uh, topic to maintain the dimensions in the objects. With the help of this open die forging, we have a minimized production rate. There will be low production rate. Okay, and at last we required machines to get the final shape to the objects. With this having some disadvantages. From overcome this, we have the second type, that is closed die forging. Okay, closed die forging is a precision forging in which entire volume of the work material is enclosed within the die. No material is allowed to escape from the die or mold during the forging process. Okay, if you say open die, there will be no enclosed the workpiece material, but if you say die structure, here it will be enclosed within the that die. The material is enclosed within the this die only. If you see this one, okay, so it is called as the closed die forging. Okay, if you apply the force on the upper die, it will be takes the whatever shape of the die, it will takes automatically here. Clear? The difference between open and closed die forging. See, in closed die forging, the workpiece is deformed between two dies, which carries the impressions here. The required size and shape the impression of desired shape of the product. The top die is attached to some reciprocating machines or rams, while the bottom die is attached to the anvil or press bed of the machine. The heated workpiece is placed in the bottom die, and the ram falls down, that causing the top die to force the heated metal to fill the contours of the that die blocks. The ram may impact the workpiece several times to ensure all the contours are filled. Okay, finally we get the desired shape of the object. The desired final shape cannot be obtained by forging the workpiece into the die cavity. Instead, some pre-forging steps are always necessary, and these steps can be using open die forging or impression die forging process. We can complete it. These processes bring the workpiece much closer to the final configuration. Okay, which is then completed with the help of closed die forging process. Now, if you see some advantages of this process, it is suitable for small and medium sized components and in large quantities. Okay, and due to this, we get the closed dimensional tolerances can be achieved easily. Also, we can get a good surface finish with the help of this process, closed die forging process. If we see some disadvantages, this is not suitable for large size components, and also initially die cost is high. Yeah, these are the some disadvantages of closed die forging process. Okay, in forging process we have the two types. The first one is the open die forging, and second one is the closed die forging. Understood all of you? Next we move to the forging machines and equipments. In that we have the first one, a drop forging, then press forging, then forging machines and equipment. See, first drop forging means, in drop forging the various types of hammers are used to apply the pressure. So with the help of hammers, you can directly apply the force on the surface of the die. The top half of the die is attached to the hammer, while the bottom half is fixed to the anvil, where you have to place the workpiece. The pressure is applied by repeated blows from the top half of the die. Here the top die is only moving, Okay, and bottom die is in stationary position. The heated metal kept in the bottom half of the die. In this close impression dies are used. Okay, this is nothing but a drop forging. If we say a press forging, in press forging, instead of rapid impact blows of hammer, the heated metal is slowly squeezed under pressure into the required shape. Here we use the pressure, squeezed pressure instead of a impact force from the hammer. The press forging also used closed impression dies. Okay, in raw forging, a large proportion of the energy is dissipated near the metal surface and the hammer foundation. Therefore, it is not possible to force large sections by drop forging. It is only suitable for a certain products only. But larger sections can be successfully forged by using press forge. Okay. Now we say what are the different machines and equipments of the forging. There are different types of the machines used to perform forging operations, and these machines are classified as the first one is hammers, or it is also called as the power hammers, and second one we have the presses and power presses. The power hammers means also referred as forging hammers. Their power from the you can say the kinetic energy of a ram, that is called as the hammer, and the top portion of the die when put into motion. See that a ram is raised to some height, then suddenly have to leave it. That kinetic energy converted into potential energy. They have to call it as the drop. Then the potential energy is converted into kinetic energy. To see the next figure, you can easily understand the power hammers. Power hammers derive their power from the kinetic energy of a ram or hammer. It is movable, and the top portion of the die, when put into motion, the ram is raised to a predefined height where it stores potential energy, and suddenly have to allow the drop into below. That potential energy converted into kinetic energy. Simple mechanism it is. Up and down. You have to lift the hammer and leave it. Due to gravitational energy, it will come down. If you lift it hammer, there will be stored in the kinetic energy. After leaving, that kinetic energy is converted into potential energy. If you see this diagram, we have the first type in the power hammer, that is board drop hammer. You see the figure, simply figure, that is board drop hammer. In this diagram, we have upper die is attached to the ram. Okay, this is a ram structure. This is upper die, and this is lower die. Lower die is connected to the anvil. This is fixed. Above, have to place the billet or workpiece or product. See, this all component is arrangement. Upper die is fixed on the ram. Okay, and this is vertical line we called as the board. It is in between two frictional rolls. The use of these rolls to lift the this ram up and down. Okay, so in a board of hammer, upper die is attached to the ram while lower die to the anvil. So the ram is attached to some attachment that we called as the that frictional rolls to moving this up and down conditions. Okay, the rollers can be raise the board and then ram due to frictional forces between the board and the rollers. So once the ram reaches the highest point of the stroke, then the roller separates, thereby losing the grip on the wooden board. It will fall down to the for working condition. When the top die comes to contact with the workpiece, immediately the board is lifted upwards and against release the provided next blow. Okay, this will be repeats. Okay, it's a simple type of the power hammer, that is board drop hammer. You take the sketch for this figure. You have the rollers, in between have the board. and ram attach the upper die. This all arrangement is moving up and down. Just to take a sketch, a line diagram of this diagram. So next we have the power drive hammer, one more, that is steam hammer. The arrangement is same. Force is applied on the billet. That arrangement is different. Here we use the board drop hammer. But in next we have the steam hammer. The steam hammer, the simplest form, it consists of cylinder with two parts, okay, and a reciprocating piston connected to the long piston rod, ram and anvil. The upper die is attached to the again ram, while the lower die to the anvil. Yeah, same in the board drop hammer. Again the bottom die is stationary here. Okay, it will contains the lower die. Above that we have the workpiece. Okay, if you see the working of this steam hammer, initially the piston will be at the top dead center. Okay, as we see in the dashed lines, the downward stroke of the ram is obtained by the exhausting the steam from one side. Okay, and then the piston admitting pressure the steam from the above that top dead center. The ram is accelerated by the steam pressure. In addition to this, we have gravity force, then it will automatically come down. Okay, again you have to release the steam here to lift the this piston. Okay, you have to add the steam from here to apply the pressure on the piston. After working, again you have to add the steam to lift this piston from top dead center. Okay, so this will be continuously takes place during process upper port, nothing but steam in here. Okay, and here we have the lower port, steam in for lifting the ram. Okay, from this steam also exhaust. Okay, once you apply the starting steam here, the piston comes down. During that time the steam should be exhaust from this port only. Again at same port the steam will be go inside to lift the ram. Okay, this condition, if you say this is the piston at bottom dead center, if you lift the piston here, piston at top dead center, and this is our piston rod. Okay, this is a ram. A ram is moving up and down, and ram just carries the upper die, and here we have the hot metal, and below we have the lower die. In between lower die and upper die we have the hot metal, or it is called as the billet. And at last component we have the anvil. This is supporting to the upper die. It will attach to the upper die. Understood? Any doubt here in a steam hammer? Okay, take this figure first. Take this cylinder. Okay, and here you write upper port and lower port. The upper port for steam in for forging. Okay, this is cylinder. Okay, and this is our piston rod that is connected to the piston to the ram. Okay, this is our ram. Okay, ram connects to the upper die. This whole structure is fixed in one line. Okay, here we use steam to operate this RAM. Now how much steam is required for this one? How much pressure is required? May be vary. The steam range may vary from 6 to 80 kg. Okay, depending on the size of the object here. To draw this figure, so today we discuss about the what is mean by forging. Okay, and also we see the different classification of the forging process. Next we see the forging machines and equipments. In that we have two types: hammer or power hammer, then presses. With the help of hammer we have this certain machines. With the help of presses we have the different machines. So with the help of hammer or power hammer we studied steam hammer and ball drop hammer. With the exam point of view, these are most important. Next class we go through the presses, the power presses. In that we have the mechanical press, hydraulic press and screw press. Over. All of you taken this figure. I will stop here. Wait for 2 minutes. We will take the attendance. And already told all students take the test of the COVID-19, because the next week will start the labs. If you have the report of the COVID-19 only, you have to give the permission to attend the labs. Okay, and also the undersigned from your parents. So this is compulsory to attend the labs, to take the COVID-19 test report and submit to the department. Okay, I'll stop here. We'll see you in the next class.